Hi, welcome to the tutorial on feature scaling. By the end of this topic, you will be able to explain what is feature scaling, list different techniques used in feature scaling, apply feature scaling using Python. So this brings us to the last stage of our data pre-processing. Before we begin our modeling exercise with the processed or model-ready data. Let's understand what feature scaling is all about. As the name suggests, feature scaling is all about scaling the feature variables, that is, all the independent variables into the same range. For understanding this, let us look at the descriptive statistics of X dataset. We see that our dataset contains variables which differ in magnitude and range. For example, lot area, flat area, etc. have a magnitude of 1000s and the range, that is the difference between the minimum and maximum, is also in thousands. While variables like number of bedrooms, bathrooms, etc. are in single digits and their range is also in single digits. The variation in magnitude and range of features causes two problems. Let's discuss them. When we build the model, variables with higher magnitude and range will have more impact compared to the ones which are smaller, and as a result of which, your model might not predict properly since it is not giving equal weight to both the variables. The gradient descent algorithm that we use to find the coefficients of linear regression may take a long time to converge if the variables are of different magnitude and range. We will study about the gradient descent algorithm in more detail in the subsequent modules. Now, to overcome these problems, feature scaling is used. In feature scaling, we scale the variables to have similar magnitude and ranges so that model is not biased towards a particular variable. Feature scaling is a must for those algorithms where some measure of distance between the data points is involved, like logistic regression, linear regression, k-nearest neighbors, principal component analysis, etc. However, it is not required for tree-based algorithms like random forest, decision trees, etc. We will study some of these ML algorithms later in the training. There are different techniques which we can use for scaling our feature variables. Some of the most common methods are standardization, min-max scaling, and normalization. Let's talk about them one by one. Standardization. Standardization is the most common scaling methods used in machine learning. Standardization rescales the feature values so that they have the properties of a standard normal distribution with mean as 0 and the standard deviation of 1. The scaling is done by deducting the mean of the variable from current value and then dividing by the standard deviation. Min-max scaling is one of the simplest methods for scaling. The value range for the transformed variables lies between 0 and 1. The scaling is done by subtracting the minimum value from the current value and dividing the difference between maximum and minimum values. Normalization is another of the scaling techniques where the range is fixed from -1 to 1 and is quite similar to the min-max scaling, which we talked about earlier. It is also called mean normalization. Here, we subtract the mean values from the variables and divide it by the difference of maximum and minimum value for that variable. So we now know the theory of feature scaling. Let's see how that is done using Python. We will be using standardization method for scaling the feature variables in our dataset since we are building a linear regression model which assumes the input variables to be normally distributed. We will be using the pre-processing library of sklearn to do the standardization for us. Let's first import the library. Next, we create the object scale. For that, we write the code as shown on the screen. Next, fit and transform the data for XTrain, which contains all the features for the trained dataset. For that, we write the code as shown on the screen. Now, let's see how the scaled dataset looks like. The dataset has been scaled and been converted into an array. If you notice, the dummy variables have also been scaled, and hence you find the values have changed. It is optional whether you want the dummy variables to be scaled or not. It depends on individual decisions. But it is always better to scale all the variables. Now, let's scale the features for the test dataset. We are only going to transform using the standard scaler as we have already fitted in our training dataset. Let's write the code for that. So now that concludes our pre-processing steps, and we are all good to go for the modeling which we are going to see from the next module.